So from the investigation we did, we sort of looked at functions could have negative areas. Now, the next sort of section and the build-up on this is where we're going to look at the area between two functions, and we end up with this definition. If two functions f of x and g of x intersect at x equals a and x equals b, I haven't put this in properly, let's just do it in black. So this value here would be a, and this value here would be b. Okay, and f of x is greater than or equal to g of x. So this means that f of x is higher than g of x for all the points between that intersection. Then the area of the shaded region between their points of intersection is given by the area of x equals a to be f of x minus g of x dx. So this function here, we're going to take away the lower function, or alternatively, if the upper and lower functions are y equals y subscript u and y equals subscript l respectively, then the area is the integral from x equals a to b of y upper minus y lower with respect to x. So let's just do this together. Okay, so let's go to the blue. So it's use the integral of x equals a, b of y upper take y lower dx to find the area bounded by the x-axis and y equals x squared take 2x. So we'll quickly draw the function up. So the first step, and maybe we'll build a checklist while we do this. So I'm going to draw this. Your first step here is you need to graph it. You need to check what it looks like. Now, this particular one isn't too bad because it has the x-axis. So the x-axis has the equation of y equals 0. So it means one of our functions here is y equals 0. And then we're looking at our other function, which is x squared minus 2x. Now, a trick to this one is if we can factorize this, we pull out a common factor of x, we get x minus 2. This means that our x-intercepts are going to be x equals 0 and x equals 2. So we're going to do 0 and 2 here, which were our intercepts, and then we're going to draw our parabola through there. Is it going to clean it up for me? No. I'm just going to try one more time in case it makes a neater curve. No, but that'll be fine. So we've got y equals x squared minus 2x here, and we're looking for this area here. Now the reason this graph, and this is why our graphics calculator helps us a lot, is this lets us think of what our upper and lower function is. So you'll notice here that this one here is lower than x equals 0 for the bit we want. This is the only bit they're bounded. Otherwise, they don't enclose the area. So this one here is going to be equal to y lower, and this one here is going to be y upper. That's our upper function. So let's think about doing the integral of this. So we're going to look at the integral from 0 to 2. That was figured out by these intersection points. And then we've got our upper function, which is 0. Or should we put our... let me write it out properly. So we've got the integral area bounded is going to be y equals 0, not 0, x equals a to b of y upper take y lower with respect to x. So then our next line here, we've got x equals 0 up to 2. So that's 0 and 2 there. They're our x coordinates. And then our y upper was 0 minus... and our lower function is this function here, x squared minus 2x dx. So now this is a definite integral. So our next step is we're going to put these boxes here. The integral of 0 is 0. And so then we've got minus, and we're going to have x cubed over 3. I should have expanded this first, I think. It will... So integral 0 to 2. The reason I'm doing these extra steps is so we don't miss any signs here. So this, I'm going to multiply this negative in here. It'll just make life a little bit simpler. The 0 is just 0, so we've got minus x squared, and then we've got plus 2x. And so this is all with respect to x. We don't have that, and I highly suggest getting rid of these negatives. Too often the negatives is where we drop marks in integral calculus. So then our next step is plus 2, and then we've got x squared over 2. They will cancel nicely, and we're going to be left with 0 and 2 here. And so our next step here, sub the values in. Our upper bound is going to be minus 2 cubed over 3, and then plus 2 squared. And then we've got minus, we're going to have x negative 0 cubed over 3, and then plus 0 squared. So that will just equal 0. So our next line here is going to equal negative 2 cubed is going to be negative 8 on 3. So you've got to be really careful here. You don't put the negative in the power. So this, if I was putting it in my calculator, I would have put brackets around that to make sure I don't include the negative. So negative 8 plus 2 squared is 4. And then I've got minus 0. Minus 0. So this is going to equal 12 on 3 minus 8 on 3, which is going to equal 4 on 3. Therefore, the area is 4 on 3 units squared. Okay, now I'm going to quickly go through this because that one's an easy one, but we need to be sure that for the x-axis that we know that function. But in this particular one, we should be making sure our first step is to sketch the graph. With our graphics calculator, so with GC. Find points of intersection and that's with the graphics calculator as well. We've got shade in required area and label with a capital A, which I didn't do in that one. So I should have had A here for the area. And then using algebra, so algebraically, find the definite integrals. Oh, hang on a sec. I probably should have moved this a little bit further along. There is one step. Here, determine y upper and y lower. Algebraically find the definite integral. and then we check with graphics calculator. Graphics calculator and state areas with units. So I wanted to do that before. I wanted to do one beforehand, so we've got those steps now. So let's jump to the next one here. So let's go. So I suggest you pause this if you're doing this yourself, because it's worth having a go here, because we've got our formula. So the first step is we need to sketch the graph. So put that in your graphics calculator. We've got y, x, and let's change them to black. Okay, we've got our graph here. So x plus 2 is going to be a straight function like this that goes through 2. But I'm going to have to draw mine not to scale. So I'm going to move it down a touch just because I'm going to run out of room, I think. So I've just sort of changed that a little bit. Okay, so this one here is going to be y equals x plus 2. Let's change colour. Let's go to the green for our next one. So x squared plus x minus 2. So this function here is going to be a parabola. Pretty much, I'm going to put it in my graphics calculator now, just because this one, I may as well get them going. I may as well have them in my graphics calculator and make it a bit easier. X squared plus x minus 2. So I draw the graph, I can see the shape, and this is in your textbook, so I've just got the 2 in there. So I end up with this negative. I end up nicely with a intersection point here, and then my other intersection point is at 2 and 4. So this coordinate here is 2 and 4. This coordinate here is negative 2 and 0. And then the function goes up like that, and we see this parabola like this. So we've used our graphics calculator, we've got our areas. We now are going to be calculating the area in here. So let's give it a label of A. And so we're finding area equals the integral from x equals A to B. And we need to figure out what y upper minus y lower with respect to x is. So let's identify our functions. So we've got here this function here, the parabola is our lower function, which means our straight line is our upper function. So we're going to have here the integral, our lower x value intersect is this one, negative 2. So we're going to go from negative 2 to 2. So we've got x equals negative 2 up to 2. My upper function is x plus 2. My lower function here is, I didn't label it here, x squared minus x minus 2. And this is all with respect to x, so I can't forget my dx here. All right, so next step here, let's simplify it first so the definite integral is easier. So if I multiply out this negative here, I'm going to end up with negative x squared. So I'm going to move that to the front, negative x squared. I'm then going to end up with plus x. Oh, hang on, that should be, so I'm going to end up with negative times positive. I'm going to end up with negative x. So x take x is going to give me 0. And then I'm going to have negative 2 will be plus 2. And so it's going to be plus 4. So now, because I've cleaned that up, it's significantly shorter. So next step here, let's take the integral. So we use our box here and we put our bounds x equals negative 2 up to 2. We're going to have that negative stays with the x squared. We're going to have that becomes x cubed over 3 and then plus 4x, which is pretty good. And then our next step here is going to be put our values in. So we're going to be looking at, so I don't need that boxy bracket anymore. We're going to go negative, and it's going to be 2 cubed over 3, and then plus 4 times 2, close bracket, and then we've got negative. We're going to be looking at negative 2 cubed over 3 plus 4 times negative 2, which is going to be negative 8 on 3 plus 8. And then I'm going to leave this second set in a bracket just to work them out. So this is going to be negative 8 times a negative is going to give me positive 8. So I'm going to have 8 on 3. And then I've got take 8 here. Okay, so putting them out, I'm going to have negative 8 plus negative 8 take 8. I'm going to end up with negative 16 on 3. 8 plus 8 is going to give me 16. Okay, so here this is going to end up being, I'm just going to go straight to my calculator just to finish this calculation. 16 take 16 on 3 gives me 32 on 3, which is my exact value. And then if I wanted to write it rounded, it's going to be 10.6, or it's 10 2/3, which we can sort of see from that. And then because this is an area, therefore the area is 10 2/3 units squared. I'm sorry, this one's taken a bit long, but I want to get through all three for you so we are in a good spot. So find the area contained by y equals f of x and the x-axis. So we're looking at where this and the x-axis intersects. So let's just draw our graph line. Okay, now I do suggest you use your graphics calculator again, because that's what we're doing, but you can either do it as roots. You can either plot two functions, or you can use the root function in GSolve. So I'm going to do that. So x cubed, I'm typing this in my calculator, that's why you're not seeing anything, plus 2x squared minus 3x. I've typed that in the graphing mode, and sometimes it is handy to, for us, this has a common factor of x. If we pull that out, we're left with x squared plus 2x minus 3, negative 3. This actually is going to factorize nicely here, because negative 3 is plus 2 and negative 1. No, negative 3 is 3 times negative 1. So this can be x minus 3, x plus 1. And that's giving us our three different intersects. We've got here x equals 0, x equals 3, and x equals negative 1. So they're going to be the 3 times this function hits the axis. So we're going to have, let's call this negative 1, 0, and then 1, 2. We'll call this one 3 out here. Okay, and once we draw it, we should see I've missed a sign here, because I've got draw. No, I haven't. I've actually got my values wrong here. That should be plus, and that should be minus. So that's a mistake I would have known with the graphics calculator. So that means my graph is wrong. So we'll get rid of these blues because we need to move our axes. So let's just grab this and drag it over to about here. Now, so we've used our graphics calculator. We'll quickly mark up our points. So we've got 1, 0, and then 1, 2, negative 3. And just looking at my graph, I don't really need to know the max and min, but it can help graph. I'm going to have my function looks like this. And now this is more complex, this question, because we've got area here, which will be a definite integral. And then we've got an area here, which is a different definite integral, but it's going to be negative here. So I'm going to call this area 1 and area 2. Now, area 1 here is going to be the integral of f of x dx between, that should be negative 3 and 0. And then area 2 here is going to need to be the integral between 0 and 1, depending on the way we want to do this, f of x dx. Now, our upper and lower formula actually figures this out for us. So as long as we break the intersections up and we look at the upper and lower, it's going to work for us. So I'm going to do, I've just sort of explained that, but I'm going to do it as the area equals definite integral. Now we need to break this up. So we're going to do negative 3 to 0 because we can see that one of the parabola, the polynomial is on top there, and then the next section is below. So this is key here, this 0. And so our upper point there for this value here is the polynomial. So we're going to go y upper minus y lower, and that's with respect to x. So that's the area of part of our curve. And then our next bit is going to be the integral from 0 to 1, because that's where our final intersection point is. And that's going to be y upper minus y lower dx. Now I'm broken it into two parts, okay, because we're going to need to do these integrals in different ways. So the first section we're going to need to do, well, the y upper is our function. So let's just put that in here. So we're going to go, this first integral is x equals negative 3 to 0. And our function is x cubed plus 2x squared minus 3x. And then this other integral here between x equals 0 and 1, we're going to look over here, and you'll notice here our upper is actually the y equals 0 function and our lower is the polynomial. So we're going to put that in here. We're going to go, well, this would be 0 and then minus our lower, whereas here would have dropped a mark or two here for poor notation. So this bit here, that's our y upper minus 0, which is our lower, and that's all with respect to x. Okay, and then our next bit here, 0, take our function here, which is x cubed plus 2x squared minus 3x, all with respect to x. Okay, so this is going to equal, once I clean that all up, this one here, all we've got is the 0. We don't need to change any signs or expand anything. Let's go straight into our integral. So we're going to have x to the 4 over 4 plus 2x cubed over 3. And then we've got minus 3x squared over 2. And that's from x equals negative 3 up to 0. And then this next one here, we're going to have this whole thing, this negative sign. If you actually remember some of our properties of definite integrals, I can pull that out the front here, and I should have done it in that step before. So I'll write it nice and small. This can be rewritten as the integral from x equals 0 to 1 with a negative sign out the front, and then it's x cubed plus 2x squared minus 3x, all with respect to x. And this means it's the same. The reason this is really handy is it means if I just put a negative sign out here, these two integrals are the same. Okay, so then I can go, well, let's put this in. So actually, let's show you how lazy I can be. So I'm going to duplicate that and drag that over here because I can put that just there. And now I just got to put my bounds in at the end. So we've got x equals, my lower bound here is 0, my upper bound is 1. Perfect. So this next one, we're going to go equals, we're going to sub our values in. So we've got negative 3 to the 4 on 4, okay, plus 2, negative 3 cubed on 3 minus 3 negative 3. Oh, hang on a sec. I've stuffed up again. Gosh, head's all over the shop. So, sorry, the upper bound here is 0. So our first step is going to be 0, and then it's going to be minus all these values that we put in. So we haven't actually stuffed up too bad. We could fix that. All right, and then we've got minus here. 0 is my lower bound, so I just need to put all my 1s in. I've got 1 to the power of 4 over 4 plus 2, 1 cubed over 3 minus 3 to the 1 squared over 2. And this whole thing is going to be minus 0 as well. So those zeros are going to go. We can start to simplify. So it looks big and complex at the moment, but we're going to simplify this down as we go. So these negatives should clean out for us. So I'm going to leave this negative at the front. We're going to do it algebraically because if I can check this with my graphics calculator, but to get an exact value, it's better to do it this way. So negative 3 squared, negative 3 to the power of 4 is negative 81. So we've got negative 81 on 4. And then plus negative 27 is that next. Sorry, that's positive 81. Okay, so the next one here is going to be negative 27 times 2, which is going to give us negative 54 on 3. 4 divided by 3, that becomes 18, so that's going to be nice. And then this next one here is going to be 9 times negative 3, which is going to give us negative 27. Negative 27 on 2. So I'm going to close that up now. And then here we've got negative. These are all going to be nicely 1s to the power is going to give us 1. So let's just quickly, going to have a quarter plus 2/3 plus, not plus, minus 3 on 2. Okay, getting there now. It's starting to clean up. So I'm going to be a little bit lazy here, and I'm going to put it in my calculator. 81 on 4 minus 54 on 3 minus 27 on 2. This all comes out to be negative 45 on 4. Okay, and then this other bit here, we've got 1 on 4 plus 2 on 3 take 3 on 2. Which equals negative 7 on 12. So negative 7 on 12. Let's put these together. So we've got negative bracket negative 45 on 4 bracket minus 7 on 12 equals 71 on 6. 71 on 6, which is going to be it's going to be 11 11 and sorry 11 times 6 is 66, so there's 66 plus 5, it's going to be 11 and 5/6 here, and then this is therefore total area is 11 and 5/6 units squared. Now, sorry, this has been a long video, and I do apologise because there's 3 examples in it. When you're checking this on the graphics calculator, you'll graph this, you'll see it, but you'll need to make sure that you don't just, if you do the integral of the whole thing, it won't give you the area. You need to make sure you do the integral of parts. All right, thanks for bearing with me for that.